What if I told you that falling into a black hole would let you see the back of your own head? And I'm not talking about mirrors or cameras. I'm talking about your actual head, in real time, standing right next to you, staring off into space. I know that sounds absolutely insane, but stay with me, because what you're about to discover is going to shatter everything you think you know about reality. And here's the terrifying part. This isn't science fiction. This is real physics that Einstein himself called where God divided by zero. Today, I'm throwing you into a black hole, literally. And we're going to watch together as the laws of physics break down, time stops making sense, and you experience some of the most mind-bending phenomena in the entire universe. By the end of this video, you'll understand why some scientists think black holes are proof that our reality is just a simulation. But before we dive in, comment below right now. Would you actually volunteer to fall into a black hole if it meant experiencing this? Because what happens at the end is so controversial that some physicists think we should never be allowed to try. Let's start with the basics, because black holes are hands down the scariest, strangest, and most horrifying objects in our universe. When massive, extremely dense stars reach the end of their lives, they collapse and leave behind absolutely nothing. No surface to walk on, no physical object to touch, just a singularity. A single mysterious point in spacetime with infinite density and infinite gravity. Now here's what makes this so disturbing. Einstein's general theory of relativity gives us one revolutionary idea. Gravity isn't a force pulling on you, it's spacetime itself bending and warping because of mass. This completely explains why we orbit the sun, but more importantly, it explains why black holes are even black in the first place. When you look at a black hole, there's no physical black surface floating in space. The singularity hidden inside is so impossibly dense that spacetime warps so much it creates a well with vertical walls. This makes it impossible for anything, even light, to escape. Because to escape gravity this strong, you'd need to travel faster than the speed of light. And we all know that's impossible. Here's the crazy part. When Einstein discovered this in his equations, he didn't believe it. He thought nature would never allow something this absurd to exist. In 1939, he actually published a paper arguing that stars collapsing into singularities was ridiculous and couldn't happen in our universe. But ironically, that exact same year, Oppenheimer, yes, that Oppenheimer from the movie, published a paper proving that stars absolutely could collapse into black holes. Einstein was wrong. And here's something that will blow your mind. Anything can become a black hole, and I mean literally anything, even you. A German physicist named Karl Schwarzschild discovered that any object, whether it's a star, a planet, or a human being, can become a black hole if you squish it small enough. Let me give you some examples that will make your brain hurt. Our sun? If you compressed all its mass into a sphere just 3 kilometers wide, boom, black hole. Earth, squish it down to about 9 millimeters, roughly the size of a marble, and you've got yourself a black hole. A human, you'd have to be crushed down smaller than a proton, way smaller. But if you somehow got that tiny, you would become a black hole. Let that sink in for a second. You have the potential to become one of the most destructive forces in the universe. You just need to get really, really small. Alright, if you're loving this so far, smash that subscribe button, because we're about to actually throw you into one. And trust me, what happens next is going to mess with your head. Now, which black hole should we pick for your journey? We could go with a tiny one, but that's boring. We could pick one of those supermassive monsters with event horizons bigger than our entire solar system, but that's overkill. Let's go with something closer to home. Sagittarius A star. The supermassive black hole sitting in the heart of our Milky Way galaxy. You're actually orbiting it right now as you watch this video, and it's one of only 2 black holes we've ever photographed. Here's the plan. You and I fly out there together and park our spaceship 1 trillion meters away from the event horizon. Then I'm sending you out towards the black hole while I stay on board and watch. But here's where things get really weird. General relativity tells us that time near a black hole is experienced completely differently than time far away. We saw this in Interstellar, remember? 1 hour on that water planet equaled 7 years back on the ship. So to keep track, we give you a special watch that shows 2 times. One for how long has passed for you, and one for how long has passed for me back on the ship. We sync the watches, you wave goodbye, and off you go on your one-way trip into the abyss. As your journey begins, you see the black hole in the distance, rapidly consuming material and superheating it due to friction. The light from this accretion disk would normally be bright blue or white, but in simulations, scientists make it orange so we can actually see what's happening. You check your watch for the first time. 30 minutes have passed for you, and you're about 0.1% of the way to the event horizon. Back on the ship, I've only gained 11 seconds. Not too bad, right? Now we're getting closer, and things are starting to look strange. The curved spacetime around the black hole is bending light in impossible ways. You're seeing light from the sides of the black hole, and even from behind it, wrapping around and hitting your eyes. It's like reality is glitching. You check your watch again. 2 hours have passed for you. You're 1.4% of the way there. But back on the ship, I'm now 44 seconds ahead of you. Time is starting to stretch. The shadow of the black hole, that dark region in the middle, seems to be growing faster than it should. Again, this is because of gravitational lensing bending light rays that would normally pass by you straight into your retina. After what feels like forever, you check your watch again, and what you see terrifies you. From your perspective, you've been falling for about 12 hours. But for me, back on the ship, I've been watching you float toward that black hole for nearly 15.5 hours. We're getting close now, and things are about to get absolutely insane. But before you reach the point of no return, you arrive at the strangest, most magical place in the known universe. If you could freeze yourself right here and look around, you wouldn't believe your eyes. You've arrived at the Photon sphere. This is a region of space around the black hole, where gravity is so perfectly balanced that light itself can orbit. Not objects reflecting light, not matter emitting light, just photons of light trapped in orbit around the black hole. And here's the part that sounds like pure fantasy, but is 100% real. If you froze at the photon sphere and looked around, you would see multiple copies of yourself. You'd see the back of your own head, staring off into space, standing right next to you in real time. No mirrors, no cameras, no technology, just space-time itself warping so intensely that light from the back of your head loops around the black hole and comes back to your eyes. You are literally looking at yourself from behind. Some scientists say this is one of the most beautiful and terrifying consequences of Einstein's equations. Comment below if this breaks your brain, because it should. Alright, let's keep going, because we're about to cross the event horizon, and what happens next is going to get dark. Literally. As you get closer, the black hole starts swallowing your view. It feels like darkness is wrapping around you, consuming everything. This is because space-time is so warped that you're not just seeing the front of the black hole's shadow, you're seeing the back and sides of it too, all at once. You've now been falling for 13 hours. In 24 minutes, you'll cross the event horizon. But back on the ship, I've been watching you for nearly 20 hours. 18 minutes later, you check your watch again. For me, 18 hours have passed. The last 18 minutes for you lasted 18 hours for me. And then, it's time. After just 6 more minutes, you cross the event horizon. You close your eyes, take a deep breath, and look at your watch one last time. But something's wrong. The watch says I've been watching you for an infinite amount of time. But the watch isn't broken. The physics is correct. From my perspective on the ship, I spend decades, centuries, literally forever watching you inch closer and closer to the event horizon. Eventually, you become so redshifted that I need an infrared telescope just to see you. I never get to see you cross the event horizon. Even if I lived forever, I would never see it happen. The last 6 minutes of your journey literally lasts an eternity for me. I know this sounds like complete science fiction, but it's not. This jumps straight out of Einstein's equations. This is real. Now you're inside the event horizon. So what happens here? Strangely, you'd have a hard time even knowing you crossed it. You can still look out and see the stars. You can even see our ship floating in space. But all of that light, just like you, is now destined for the singularity. You are past the point of no return. To escape now, you'd need to travel faster than the speed of light, which is impossible. A lot of people think that once you cross the event horizon, you'd watch the entire future of the universe unfold in front of your eyes because of time dilation. But that's a myth. Due to something called aberration, as you get closer to the singularity, the entire outside universe gets squished into a thin little ring, and eventually it disappears entirely. And then comes the final stage, spaghettification. Your feet are closer to the singularity than your head, so they experience stronger gravity. Your body gets stretched, your bones dislocate. You're pulled apart atom by atom in the most violent way imaginable. And then you and the black hole become one, wandering the universe together for eternity. So there you have it. Falling into a black hole would let you see the back of your own head, experience time in ways that destroy reality as we know it, and ultimately get ripped apart at the atomic level. Now tell me, after everything you just learned, would you still do it? Would you volunteer to fall into a black hole just to experience the photon sphere? Drop your answer in the comments, because I genuinely want to know. And if you made it this far, you're officially part of the Curiosity Beast family. Hit that subscribe button because tomorrow we're exploring something even darker. Thanks for watching, and I'll see you in the next one.